Welcome to the notes on rectangles. So, rectangles, what you've learned in the past, here's your rectangle, that you have two short sides and two long sides. So what we want to add to that, a rectangle is a parallelogram, so it has all your properties of a parallelogram, but it's with four right angles. So first thing we have to know it's a parallelogram, and second we have to know that it has four right angles. That's what makes a shape a rectangle. Just the opposite sides congruent. That's what makes it a parallelogram. So also a property that we know about rectangles is the diagonals are congruent. So from J to L is the same as from K to M. So we can take it a little bit beyond that. Because I know the diagonals are congruent, and I also know because it's a parallelogram, they bisect each other, that all of these little segments on the diagonals are congruent, which then makes all of these triangles isosceles triangles. Then if you remember, that means all the base angles are congruent in each of these triangles. So we're going to use that property in just a minute. So first, let's start with our example here. We have a rectangular garden is reinforced with diagonal braces to prevent it from sagging. So we have a rectangle here. It says if JK is 12 feet and LN is 6.5 feet. We want to find KM. So if we notice, KM is my other diagonal, and it's the entire diagonal. What it gave me was this half of the diagonal. So since I know the diagonals are congruent, the entire diagonals are congruent, that means the entire length of this diagonal is the same as the entire length of that diagonal, which would then tell me that KM is 13. So what I want to do is I want to go ahead and add on to that. And I'm going to add another question here. Well, if I know KM is 13, I want to go ahead and find JM. Well, if you remember, because this is a rectangle, this is a nice right triangle from K to J to M. So that's a right triangle, which then in turn means I can do the Pythagorean theorem. So 13 is now my C, so to find JM, we'll do x squared plus 12 squared equals 13 squared, which then of course I square both of these and then have to subtract the 144. So to conserve space, just know I subtracted 144, so that would give me 25. And then I square root the 25, which would tell me that the length of KM is 5. So just in case that comes up in your work. Now, next thing, also on top of that, I want to take a look at some of the angles. So I'm going to erase this over here. And I'm going to go ahead and add in that the measure of angle KJN is 35. I want to start by finding the measure of angle NML. So N to M to L, N to M to L is down here. So if I want to find the measure of this angle, one thing that we can think about is we've already talked about symmetry. So I know that this is symmetric, so whatever measurements I have up here are going to match exactly down here. So that would make this angle down here 35. So the measure of angle NML is going to equal 35. Now, because NML is 35, I also know this angle over here is 35. Now, why do I mention that? Because the next angle I want to find is MNL. So I'm looking for the angle here in the middle. So because I know both of these bottom angles here and here are 35, I can use the rule of 180 for a triangle, add the 35s together, which gives me 70, so I can do 180 minus the 70, which would then give me 110, so the measure of angle MNL is 110. So that's really all the main things that you need to know about the angles. Of course, if we were looking for the angle here, these two angles add to equal 90. And just using that, a rectangle is symmetric, all the measures over here are going to match with all the measurements over here, or all the measurements on top match with all the measurements on the bottom. So last thing we want to talk about is writing equations. So again, here we have a rectangle. So I know all of these are right angles. And I also know that the diagonals are congruent. So it starts with KJL is 2x plus 4. So KJL is 2x plus 4. And then JLK, so JLK is 7x plus 5. I think the easiest explanation would be that I know the measure of this angle here is the same as this angle here. So if I look at it, I know these two angles here make that right angle, so that's going to add to equal 1. So now we're going to be talking about writing equations. So anytime you see a rectangle, you need to know that each of the corners are 90 degrees and the diagonals are congruent. So we're going to start with, it told me that KJL up here is 2x plus 4, and then JLK is 7x plus 5. So a couple ways you can think about it. I know this angle down here is the exact same measure as that angle. And then I can look at, well, these two angles together make 90 degrees. So I can make the equation of 2x plus 4 plus 7x plus 5 equals 90. Or you can just think about that these two angles are the acute angles in a right triangle, and still they would add to equal 90 degrees. So when we solve this, remember, combine like terms. 2x plus 7x is 9x. 4 plus 5 is 9, and that equals 90. And then from there we have to subtract the 9 from both sides. So that makes it 9x equals 81. Divide by your 9, and your x then equals 9. Now I also want to look at this second problem down here at the bottom, where it says we're referring to the same figure, but it tells me JP is 3x minus 5. So from J to P is y minus 5. And then also MK, so from M all the way up to K, is 5y plus 1. Now because MK is an entire diagonal and JP is only part of it, what we can think about is we can take 2 JP's to equal 1 MK. So my equation would be 3y minus 5 plus 3y minus 5, which is the same as 2 times both of those, and then equals 5y plus 1. So to solve this, again, combine like terms on the same side. That would give us 6y minus 10 equals 5y plus 1. Subtract your 5y from both sides, because remember, variables first. So 6y minus 5y would give us a 1y. Minus 10 equals 1. Then add the 1 to both sides, and that leaves me with y equals 11. So these are a couple of type of equations you may see.